Altitude prediction calculator is used to predict burnout velocity, burnout altitude, peak altitude, and coast time. Any of the fields outlined in red are required and won't calculate unless those are filled in. You can enter anything you want of these directly, or you can select from the lookups and it'll populate those. So say we have a STZ9 and the body tube is BT60. The rocket weighs 0.82 ounces. All the stuff below is calculated. It also calculates the percentage motor class and the thrust to weight ratio. And if you change anything, it'll recalculate as soon as you tap out. So notice it's grayed. The grayed area is showing your last calculation. So let's see, it's really 0.9 ounces. And it updates that. Same with the drag coefficient if you need to adjust it. If you want to calculate a cluster, you just tap in the number of motors field and enter the number, and it'll update that. The temp and elevation is used to correct for your temperature and elevation above sea level. A lot of calculators will use this by default, 59 degrees Fahrenheit, 0 elevation, but most launch sites aren't 0 elevation and 59 degrees Fahrenheit. So enter what your area is and it'll adjust the air density to give you a more correct calculation. The data assistant screen is used to calculate values that you don't have. If you have, say, 2 known values, or in the case of the body diameter, 1 known value, it'll calculate the other values needed in the calculator. So it also carries over back and forth. So if you change something here, it'll change it here, and if you change it there, it'll be back on the main screen. So, for instance, if you knew the total impulse was 4.42 Newton seconds, and you needed the average thrust, but you only had the burn time, enter that, and it'll calculate the average thrust, pulls that back in. So that's kind of useful, depending on, sometimes the data you have doesn't have one of the things you need. You can use that to help.